this tutorial, we will start the designing process for the rest of the floors that we have. As in the previous tutorial, we have finished the designing of the supply and the return air system for the second floor, and now let's jump to the first floor to make the design for it. As you see, for the first floor, it has a near structure that is very near to the second floor on the spaces that we have and on the zones also. So we have the same three sections, but there are some little changes in the distribution of the rooms or their architectural design. So the rooms are a little bit different from the second floor. And for that large similarity between the two floors, the second floor and the first floor, we can do something that will facilitate the designing operation greatly. So what we will do is to copy all of the air system design from the second floor, and we will paste it on the first floor. And then we will make the required modification on the design for each space. For example, if we go to the second floor, we will find that that space, which is that instruction room, requires 4 air terminals, and each of them is rated here, as you see, 235 liters per second. Now, if we go to the first floor for the same space, we will find that it's another instruction room, and it may have a different area from the previous room, which is aligned at the same position for the second floor. And for that, we may have a different number of air terminals, or we may need the same air terminal design, but with a different airflow through each of them. So what we wanted to say is that it's very easy to copy all of the air system from the second floor and to align it at the first floor and make the required modification. This will be more easier than if we go to this first floor with its plank design and start making the air system design from very beginning and from the very scratch of each element. So this will be a tiring operation. And for that, we go to the second floor, and then we can select the whole of the design. So I can select all of the floor, and then I press on the filter tab and we check none. Now what we need is the air terminals, the ducts fitting, the ducts, and finally the mechanical equipment. So those are the air system equipments that we need, and then we press on apply, and then we press on OK. Now we go to the copy tab, and then we go to the first floor. After that, we go to paste and align to the current view. And then it asks us if we need to save the project, so let's save it. Very good. As you see, this is the air system design that we have just aligned, and surely it needs some modifications. For example, this area for the second floor was only one space, but here it's split into 2 spaces, and for that you can see the diffuser is going at the position of the wall. So this system needs totally some changes, and we must make those changes. But at first, let's go to the entry level and do the same thing also, as it has also a similar structure. So we go to it and then go to the modify tab and paste and align to the current view. So by that way, we are pasting the same design from the second floor to the entry level as we did on the first floor. Very good. As you see, this is the design also for the entry level floor. And now we will modify the ducts and the air terminal design to be suitable for each space inside each of those 2 floors, the entry level and the first floor. But you know, we have learned it before many times how to design the duct system, and I'll not repeat those steps again, not to waste your time. But I'll take only a sample for a room and I'll modify it for you to know how the modification operation can be done. For example, if we zoom in, we will find that we have here a cafeteria, and this cafeteria has a different structure for its ceiling. So it's suspended ceiling square slabs go with a declination angle. As you see here, it goes with that angle, while the slabs for the other rooms are going vertically, as you see. So we will align the diffusers that we have, or that air system, with those declined square slabs, not to be vertically as the traditional design for each space or for the other spaces that we have. Now let's try doing so. Here we zoom in, and then you can see this cafeteria needs a total airflow to be 1486. So if we suppose that this cafeteria will be fed with 6 diffusers, here we need to calculate the airflow for each diffuser. And now let's make the modification operation. So we can select the duct and we delete it. And let's select the diffuser. And here we will align it with that slab, for example. So we go to the Align tab and select that line and then that edge. And then we select that line and that edge. And then that line and that edge. Very good. Then we can put another one. So we can copy that one. We press and copy and we pick it from that point. And then we can paste it at that position. So that's about the second one. And now for the third one, here at first, let's delete those return dots. So we don't need them now. Here we select them and we delete them. Very good. Now let's delete those earth terminals also. We don't need them. And then that one, we delete it, and that one, and that one, and also we delete those ones, and that one, and also that one, and here delete those ducts. Very good, it's more clear now. Here we select that earth terminal and press and copy, and we pick it from that point, and let's paste it here at that point, and then we can copy it another time and pick it from that point, and we paste it at that position. Then a third one, we press and copy it from that point, and we paste it at that point. So if we count them, we find that 1, 2, 3, 4, 5. So we need the last one. We press and copy and pick it from that point, and it will be a good idea to insert it here. Now what we will do is to connect the supplying ducts with those supplying air terminals. So we go to the System tab and press and duct. And then we start from that point, for example, and we go until that point, and then we make the routing operation to that air terminal. Now we make another duct. We can start from that point, and we go there until that point here, and then we make it until that point. Very good. Now we can delete that duct and that tap. We don't need it. And then for the third air terminal, we go to the duct system and start making it from that point here until that point. Very good. Here we have connected the third air terminal. And for the fourth air terminal, we do the same thing. We go to the duct tab and start it from that point until that point. More than great. Now for the fifth diffuser, we do the same thing. We go from that point, for example, and we go there until that point to that air terminal. And finally, we have that final air terminal. But before making the routing operation for it, we can delete those return ducts as we don't need them now. Here we select that one and delete it, and that one and delete it also. And then we go to the duct system and start from that point and go there until that point and then up. Very good. So that's about the supplying air system for that cafeteria. And then we delete that air terminal also. We don't need it. And finally, we change the airflow for each air terminal we have. So we select that one and that second one and that third one and that fourth one, the fifth and the sixth, and make them to P 250 liter per second. And the final thing we need to do is to connect the return air terminal system. So what we will do now is to delete those ducts. We don't need them. And then we can align that air terminal here with that slab, for example. So we press on align, and then that H with that air terminal H, here that one, and then the decline H with that decline H of the air terminal. And we will delete that air terminal. We don't need it. And then copy that one. So we press and copy and start picking it from that point, and then we paste it at that point, and then we select that one again and press and copy, and we pick it from that point, and then we can insert it at that position, and also we can copy it. We press and copy again and copy it from that point, and we can insert it at that position, and another one, copy from that point and insert it at that position. So let's zoom in. And here we insert it at that position. Very good. So that's about the supplying and the return air terminals, but it will be a good idea if we drag that one a little bit up. So we press on align and align that H with that H. More than great. So we have here 5 air terminals, 1, 2, 3, 4, 5. We need the last one, so we can copy that one again, press and copy and select that H, and we can paste it at that position. Very good. Now for the routing operation for those return ducts, we can go easily to the System tab and press on duct and start from that point and go up here until that point. And then we go to the second one. So we start from that point and go up here until that point. and then we make a third one from that point, and here we go until it. And for the third one, we need another duct that is going up here and go forward, so we can make a branched duct from that point that is going up, and then we go there a little bit, and then let's move also a little bit forward. And now let's decrease the offset of that duct to overcome the supplying duct. So we need no interference between the return duct system and the supplying duct system. So we make it to P here to 1700 and go until that point here. But as you see, we will face that diffuser, so we can press on escape, and then we select the duct and press on the down arrow in the keyboard. So we are decreasing the height of the duct not to make any problem with the air terminal system. And then we go again and insert another duct, but at that point we will make it back, or we will return it back to its original offset, which is 3150 millimeter. And then we go to the duct again, and we insert the duct from that point, but at that position we will increase its offset again to return back to 3150 millimeter. And now let's move forward until that point, and then we go to that return air terminal. Very good. Now we can take a branched duct that is going here and it's going forward to that air terminal, and another branched duct that is going here and it's going forward to that air terminal. So we can go there from that point and go forward here until that point, and then we connect it to that air terminal, and then another one that is connected from that point to that point. More than great. Here we have connected the return air terminals and the supplying air terminals. But a problem that you may face is that the return air terminal now has the same color of the supplying air terminals. This is a return one, for example, and its color is blue. And this is a supplying one and its color is blue. So this problem may appear if we make the routing operation for the return air terminal with a supplying duct air terminal. For example, if I select the duct and I go to its purpose, you will find that it's of the supply type, and this is a mistake. And for that, we will change it to P a return one, not a supplying one. And here we go. You can see its color has been changed, and also we select that one, and we select that one, and the third one, and then we go to their type that are of the supplying air. This is a mistake. We make them to P of the return air. Very good. You can see all the return air systems has been turned back to its original type, which is the return air. And for that, we can distinguish between the supplying air system, like those air terminals, and the return air system for those return air terminals. So that's about this tutorial, at which we have made the modification operation for one space, and I'll do the rest of the required modification operation myself. And for you, it will be easy now to make the modification for your system, as we have learned many times how can we make the air system, and we have faced many problems, so you can go forward and do well now. In the previous tutorial, we have modified the air system only for one space, which is that space here, or that cafeteria. But as I told you, I have prepared the modified air system, required air terminals and ducts, and you can enjoy exploring them to see all the differences in the design. So I have did that job for the entry-level floor and for the first floor. And now, after finishing all the designs that we have for the supplying and the return air system, we need now to make some checks, or to ensure that there is no problem in our design. So the first thing we need to do is to check that there is no open ducts, or no ducts that is not connected to the air terminals by mistake, for example. And let's do that operation on the second floor. Here for the second floor, we go to the Analyze tab, and then we press on Show Disconnects. And here it asks us for the components that we need to check it if there are some disconnects or not. If we need to check the disconnects for the ducts, or for the pipes, for the cable tray and conduit, for the electrical equipment. But for us, we will check the ducts, as we are making the duct system now. And then we press on OK. Very good. Here you can see the open ducts has those yellow signs. So if we go there, we will find that we have this yellow rectangle, which means that we have here an open end. So if we zoom in, we can find that this is a problem, as we have shifted by mistake the VAV box, so it was shifted from the output duct, or they are not connected to each other. And for that, what we will do easily is to go to the Modify tab, and then align, and we will align that line here to that line. And by that way, we can connect the two parts together. So to solve that problem, we can easily select those ducts here, and then we can delete them. And then we make the routing operation another time. So we select the duct out of the VAV box, and then we press a right click on that tab, and then draw duct, and then we draw duct onto that point to connect them together. Very good. Here you can see the yellow triangle sign has disappeared, which means that we have managed exactly to connect that part together, or there is no disconnects between the VAV box and the LPO. Now we need to do the same thing with the ducts here that are connected to the main duct. So what we will do now is to select all of those ducts, and then we delete them. And after that, we select the duct and press right click and draw duct. And then we go here until the middle of the central duct or the main duct out of the air handling unit. And then we go there. Very good. Here we have connected that one. And then for the second duct, we select it and press a right click and draw duct. And then we can go there and zoom in until the first point or until the surface of the air handling unit main duct. And that's it. You can see we have connected also the second duct with no problem. So the disconnection sign has disappeared from that duct and from that second one. Now we will do the same thing for the third duct. Here we select it and right click and draw duct and go until the center also, and then go there, and then we zoom in until the surface of the main duct. Very good. You can see also the third duct has been connected easily, and there is no disconnection point between that third duct and that main duct. All right, now if we go there to scan the rest of the drawing, we can see we have here a disconnection. So we have forgot to connect that main duct with that air terminal. And for that, we go to the system tab, and then we press on duct. And then we start the connection point from that point until that point here. But at first we need to change the offset. So we will set the offset back to the original offset, 3150 millimeter. And then we connect it to that point. Very good. Here we have connected our duct exactly as we need. And then we go there to scan the rest of the project. So we have no problem or we have no disconnection at that point. Also, the second check we need to perform is the interference check to ensure that there is no ducts that are interfered with each other. And for that, we go to the Collaborate tab and then press on interference check, and then run interference check, and then it asks us for the components that we need to make the interference check for it. So the most important thing for us now is the duct. So we select the ducts here and that one, and then we press on OK, and here it's loading. Now it tells us that the interference that we have are in that duct and that duct and that one and that one and that fifth one and that fourth one. So if we select any one of them and then we press on show, here it gives us the duct that has the interference. So this is the duct that has an interference, and correct that interference. Also, we can check the second one and press on show. Here it tells us that this is the second duct that has the interference, but you can see those ducts are on the first floor, not the second floor. Here we go to the third one and then press and show. And then for the fifth one and the sixth one, by the same way. Now we can press and close and go into the third floor. All right. Now, after checking the system, we need to start the sizing process of the ducts. But the problem now is that if we need to make the sizing process directly, for example, for that duct, so the program will consider that duct here to be only one duct, and for that it will give it only one size. But this is a problem here, because the airflow that will go out of that duct at this position will be higher than the airflow that will go through the duct for that position or for that particular part. This is because the airflow for that part is the total airflow for the system, but the airflow of that part here is the total airflow minus the airflow for that branch. And also the same thing, if we are talking about the airflow for the final part of that duct, for example, it will be smaller than the airflow of the first part. This is because the airflow of that part is only the airflow that will go through that diffuser, while the airflow for the first part is the total airflow that is going through that branch and that second one and that third one and that fourth one and so on. So what we want to say is that although we have one duct only, but this duct must be sectionalized into some sections, and each section of them will have some different dimensions according to the airflow through it, according to the sections that this duct or this part of the duct will feed. And this means we need the size of that part, for example, of the duct, to be larger than the size of the rest of the parts of that duct. So that part size will be larger than those part size. And to solve that problem, we will split each part of the duct at which we have a different airflow. So we will split that part from that part, and we will split that part from that part, and we will split that part from that part, and so on. And to do so, as we learned it before, we go to the Modify tab, and then we press on Split, and then we save the project. So we go to that point and we split the duct, as that part of the duct will have the total airflow that is going through all these spaces at the zone. And then we go to that part and we split the duct, and then we go here until that part and we split the duct also. And the same thing at that part, we split the duct, and here we go there until that point and we split the duct. Now what we will do is to select that part of the duct and press on tab. So press on tab another time, so the total duct has been selected. Now we press a left click. Very good, here we have selected the whole of the duct, and then we press on duct pipe sizing. And now, as we used before, we will use the equal friction method, and we will set the friction losses to P as the default value of 0.82, and then we press on OK. Very good. You can see here we have did it. That part has the larger size because it will have the largest airflow, and that part a smaller size, and that part a less smaller size. And you can see we have here a generated duct fitting because this duct fitting connects a larger size duct to a smaller size duct, and here a smaller size duct, and here the last one is the smallest one because it will feed only that air terminal. Very good. Now we will apply that idea on all of the ducts that we have. So we go again to the split command, and then we go here and split at that point, and then we go there and split at that point, and then we split at that point also, and there we split at that point, and after that we split here and we split there, and we go here and we make a split here and another split there, and we go forward also, so we have no other ducts. Now we press on escape and another escape, and then we select any air terminal like that one, for example, and then we press on tab and tab, and then we press a left click, and then we go to the duct pipe sizing, and here we will use the same equal friction method and press on OK. Very good. You can see we have managed to do that. Here that duct, for example, has a smaller size, and that duct has a smaller size, and you can see the duct has a larger size than that duct because the airflow through that duct is the total airflow for those 4 air terminals or for those diffusers, while that duct carry only the airflow through that diffuser and that second one. Also, if we go there, we will find that the duct has the largest size. This is a smaller one. This is the least one or the least size. And for that one, we have a smaller size and the least size. And the same thing here, a small size, a smaller one, and the least one. So what we did here on that zone will be applied on the rest of the zones we have, that second zone and the third zone. But not to waste your time, I'll do that myself, and you can enjoy exploring that operation later, or you can enjoy doing it yourself. In this tutorial, we will continue illustrating the required steps to finish our air system layout. Now, if we need to analyze the airflow through our system or the pressure losses, we can select the duct system that we have. So if I go to any duct like that one, for example, and press on tab and another tab, and then press a left click, then we press on System Inspector, and then we start the inspection operation. So you can see it tells us that we have here the airflow through that duct to be 3,500 liters per second, and the set pressure is 728.6 Pascal, and the pressure losses is 621 Pascal. Now, if we go there to that duct, for example, here for that duct, you can see the airflow decreases, and the static pressure also decreases and the pressure losses decreases. And for that duct, you can see we have lower values or a total airflow of 800 liter per second and a static pressure of 107 Pascal and so on. And for that duct, so we can see the airflow is only 400 liter per second. This is because that air terminal has 200 liter per second and that one has 200 liter per second and so on. So you can use that powerful operation to analyze or to see the airflow and the static pressure through each duct you have. So those are the direction of the flow through our system, and that's it. Now we press on cancel. And we use those values to choose the required VAV box fan that will push the air inside the ducts that we have. Also, we have another very important tool to analyze the airflow inside our system. So if we go to the second floor, for example, as this tool is applied only on the floors, not the ceilings, and then we can select the duct, for example, and press on tab and then another tab and select all the ducts that we have. And then we go to the analyze tab, and then you can see we have here the duct legend. So if we press on the duct legend, and then we save the project. Now it asks us for the place that we need to insert the duct legend at, so we can insert it at that position, for example. And then it asks us for the type of the legend. We need it to be according to the airflow or according to the velocity through the duct. So we can make a colored legend or a color table consists of the corresponding airflow of the ducts or the corresponding velocity of the ducts. So each value of the airflow will have its corresponding color, or each value of the velocity will have its corresponding color. So we can set it to P according to the airflow, and then we press on OK, and that's it. Very good. Here you can see the program gives us the legend here or the table as we have each value of the airflow through the duct and its corresponding color. So the airflow to P 130 liter per second has the red color, the airflow of 150 liter per second has the orange color, and the green color has 170 liter per second, and so on until the last one, or until the largest airflow we have, which is 3,500 liter per second. So this is the maximum airflow through the largest duct we have, and it has the magenta color. Now if we go there to check that on the layout, you can see we have each duct and the airflow through that duct. So if we go there, you can see those are the different colors, and each color has its corresponding airflow through it. And this is a powerful tool that enables us to know the different airflow values through the ducts only by its vision. So from the vision only, we can see the airflow through each duct. Also, we can change the setting of that duct legend. So if I select the duct legend, for example, and then I press on edit scheme, here, as we said before, we make the legend according to the airflow, and we are making it according to each value. So each value has a specific corresponding color, but we can make it according to the range. So we can give each range of airflow a specific color. Suppose that the range from 100 to 200 liter per second, we can give it the color to P, the flow, for example, and so on. So this is up to you. This is the schematic. You can set the values that you need. So I can deselect that value, for example. I can add another value that I need to enter, and so on. Now we press on cancel, and at that point what we need to do to finish our drawing is to add the required information that enables us to construct the project at the real site. And for that, we will press on Ctrl Z to return back, as we don't need those colors now. We press on Ctrl Z. And then, as our need is to make the construction engineer to read the drawing and know what are the dimensions of the ducts that we have, and for example, the offset of each duct from the floor level and its type to be a supply one or a return duct. So for that purpose, we can tag the ducts that we have from the Annotate tab. So if I go to the Annotate tab and then I press on Tag All, so it asks us for the elements that we need to tag, and for that we need to tag the ducts. So we press on the ducts and then include elements from the linked files, and after that we press on OK. Very good. You can see here we have each duct dimension. This duct, for example, is 700 by 700, and this duct is 650 by 650 millimeter. But you can see the ducts tag are very confusing and their size is large. So if I select one of them and then I go to its properties, and then I go to Edit Family. Now I can change each duct size. So if I select that size and then we go to the reports and then edit type. And here for the text size, I can make it to be only 1 millimeter instead of 2.5 millimeter. And then we press on apply and OK. And then we load into project. After that, we override the existing version. Very good. That's more pretty and clear as we have decreased the duct dimension. So this is the idea. We need the layout to be an informative one as much as possible. Now, after adding the dimension through each duct we have inside our drawing, what we need to do now is to add some dimensions that tells us what is the position of each duct with respect to the walls we have. So I'll make a sample now for those dimensions, not to waste your time, but I'll complete the rest of the layout later. And for that, I go to the dimension command. So let's start making the dimension from that point, for example, to that point. And also we can make another one here from that point to that point, and then a third one from that point to that point. Very good. Now another one from that air terminal, for example, to the end of the wall. All right, so by that way you can make the dimensions that we have for the drawing. And also we forgot to do a very important thing, which is to add the offset of the duct and its top elevation on the tagging process. So if I select the tag and then I go to edit family, now I go to its size and then select edit label, and here we have its size only, but we need also to add the top elevation. So I'll search for top elevation. That's good. We select it and double click. After that, we need to express if that duct is a supplying one or a return one. So for that, we select the system type and press it, double click on it, and then we press on apply and OK. And that's it. Now we press on load into project and then override the existing version. Very good. You can see here we have the duct dimensions and its top elevation to be 3,250 millimeter and its type to be a return one, and the same thing for the rest of the ducts that we have. So we are making our layout a more informative one as much as possible to make the required constructing process on the real site. This is the drawing of the entry-level ceiling after adding all the required details of the duct's dimensions and the vertical offset from the floor. You can explore it. We have added many details and dimensions on it to make it an informative one for it to be ready to be put in its final form. So what we need now is to put the drawing in its final form or its final template. And for that, we can handle its scale firstly. So we need to decrease its scale. And for that, we go to the scale level and we can make it to P1 to 200 instead of 1 to 100 as its default value to P1 to 100. But we will make it now to P1 to 200. Very good. You can see here the drawing has been decreased or the drawing scale has been decreased. But the problem now is that the tag itself or the spaces tags are with its same scale. So we need to decrease its scale to the half as we have decreased the drawing to its half scale. So we select it and press on edit family and then select it and press on edit type. And then we will make the text file to be the half, which is 1.5 and instead of 3. And then press apply. You can see the text size has been decreased. Now we press on load into project and then override the existing version. Also, we need to do the same thing with the dimension scale. So we can select the dimension and then edit type. And now we go down. Here we are searching for the text size. So that's the text size. It's 2.5. We will decrease it to P 1.25 and then apply. And then OK, very good. Also, the dimensions has been decreased here. So it's suitable for the drawing scale that we have decreased. And now the final thing we need to decrease its scale is the duct tag. So if I select the duct tag, you can see it has a larger size. So we go to edit family and then we select it and go to edit type. And then for the text size, we will make it to P 0.5 instead of 1. This is to cope with the change in drawing size. And then we press on apply and then OK. And after that, we can decrease its width a little bit. Very good. Now we press on load into project and then OK and override the existing version. More than great. Here we have did all things as we need. So we have decreased all the sizes of all of the drawing to be of its half scale. Now after handling the drawing scale, we need to export the drawing template. So we go to the View tab, and then we press on the Sheet option and save the project, and then we will load the A1 matrix size. So we press on OK. Very good. This is the template that we have illustrated before, and those are the information that you need to enter. Now we go to the project browser again, and what we will do easily is to drag the ceiling that we have worked on. So we have worked on the entry level ceiling. So we select it and drag it easily at that position. Very good. Here we can put it at that position. As you see, this is our final drawing, and it has the scale as we have just set it to P1 to 200. And those are all the details that we have made here. Those are the dimensions, for example, and the tags of the ducts and the spaces names and so on. All right. Also, we can add some sections to that drawing. So we can go to the elevation plan and express some sections with some other details, as it's not sufficient to have the plan view, but we need also to have some sections or some details from the elevation view. And for that, we go to the entry level ceiling again, and then we can make a section. So we go to the section tab and make it from that point to that point, for example. But let's drag it down a little bit. So we select it and drag it here. And then we can decrease its view range. So we can drag its view range down here. Very good. Now we can access it, double click on it. Very good. As you see here, those are the ducts that we have, but let's increase their details level. So we go to the details level and make it to be fine. So those are the ducts with all of their details and dimensions. And what we can do easily is to go to the dimension command and start making some dimensions to see the vertical height of the ducts with respect to the suspended ceiling surface. So we can start from that point till that point here. That's good. Now let's make another one from that point to that point. Here, that's it. And also we can go there. Here we can measure the distance from the center of that duct to the suspended ceiling surface. That's it. And also another one from that duct here until that point. And let's put it here. All right, now let's go there a little bit. Here we can measure the distance also from that point to the surface of the air terminal or to the surface of the suspended ceiling, as they have the same surface. And that's it. It's about 0.44 meter. And let's go there. Here we can do the same thing from that duct or from that return duct to the surface of the suspended ceiling. Now let's go back to our template. So we press on escape and another escape, and then we minimize that window and go back to the template. So if we go there, we will find that this is the template that we have. We maximize that window, and then we go out of it. And then to add the section that we had just created as we learned it before, we find it under the mechanical discipline, and then sections. And after that, it's the last section, section 10. We select it and drag it here. Very good. Now we can center it also. More than great. Here, as you see, we have selected our final drawing, which is the plan view, and also we have selected the elevation view with the required details that we have, or we can add all the required details as we need. This is up to you, but what I need you to know only is that this is the idea about the final form of the drawing, with many details that you will need for constructing your system on the real side. And now the final thing we need to do is to express the drawing that we have in the 3D form or on a 3D animated form. As we have learned it before, we can express the 3D form of the drawing, but also we have another strong tool, which is the walkthrough, that enables us to take a 3D animated tour inside our floor or inside our building to see how our design can be shown in the 3D form with an animated view. And for that, we can go to the entry level ceiling again. Here we drag down to the entry level ceiling, and then let's zoom in. And after that, we press on 3D and walk through. And now it asks us to specify the path at which we need to make that 3D animated tour. So we are specifying some points now, and those points represent that path. So if I press a left click here, you can see we specify the starting point, and then we specify the other steps that we need to make. So I'll press another left click. So that's the second point, and let's zoom in, and I press another left click, so that's the third point, and I go there, and another left click, and then you can see you can change the direction as you need. So you can change the direction and the number of steps. I can add another step by a left click and go there, and another left click, and also go there, and another left click, and go forward, and another left click, and go there, and another left click, and here at that point let's turn to the right, so another left click, and then we go there till the third zone. So we are expressing all these zones that we have. Let's turn right also, so we need to express all these zones that we have, or all of these spaces, and then another left click, and finally another left click at the end of the floor that we have. More than great. Now what we will do is to press on Finish Walkthrough, and then to activate that 3D animated form, we press on Edit Walkthrough, and then we press on Open Walkthrough. So this is the starting view of our walkthrough. Now you can see we have 300 frames of 300 frames. So those frames are the frames of the video, or the 3D animated video that we will perform. And for that, we need to reset it as it goes to its maximum here, but we need to reset it. So we make it to P0 now. And then we go to Edit Walkthrough again. So you can see we are moving here inside our polling, or those are the dots that we have created before. So that walkthrough gives you a good imagination of the system that you have made in its 3D form with an animated shape. As you see, those are the ducts of the entry-level ceiling, and those are the air terminals of the supplying type and the return type. And as we are on the entry level, so you can see we have also the first level upper to it, and here we are drafting to the right as we have just made, and those are the ducts that we have. And you can see this is the bridge that we have made to overcome the supplying air terminal, and here we are drafting to the right also to go to the third zone that we have, and this is the VAV box. So we are handling now the supplying and the return air terminals until going to the last space that we have inside the last zone.